I will now tell you about how you can use transmission in Odeon. And as an example here, I have a big hall in which there is a smaller office room. The office contains a door and a window, and the large hall is about 800 cubic meters, and the small one is about 70 cubic meters. You go to the material list to add the transmission indexes to the hall. Then you find a relevant surface. This is a wall, which is constructed by two surfaces, the outer and the inner wall, and you therefore add it as a transmission wall. And then you also want the inner wall at the same time, that was, to also as well be a transmission wall, because it's a double wall. So for the first one, you go into this transmission data window. Then you say, click, this is a double-sided wall. And then you want to add reduction indexes in third octaves. And I have, for the walls, I have them listed here in an Excel sheet. And you can go select the material, Control copy, go back to Odeon, click the window and press Control V. Now you have the reduction index of a gypsum board wall type. Yes, you close this. Then we go down to the other side of the wall, which now is yellow, meaning that this is as well a double wall, and it also have the same transmission index. It is also possible to model transmission as a single surface transmission. You can see that here with the door, which is only one surface. Go to that one, and now from the Excel sheet copy door material, Control V. We have that one. Do the same thing for the window, and as well for the other walls and the ceiling of the office. Double-sided wall. And this one has automatically selected the opposite. Find the ceiling. Transmission. Click double-sided. We find the ceiling in the Excel sheet. Like that. So now we have the transmission from the office to the large hall. And we save it. We can see in this example how the billiard balls will transmit some of them into the office, or if we maybe select a source inside the office. It looks like this. If we take a look at the absorption materials which are already added in the hall and the office, you can see that the ceiling in the hall is quite absorbing, and the rest of the surfaces are not very absorbing. And if we go into the office, it is the same. The ceiling is even more absorbing, and the gypsum has a little absorption as well. Okay, so now we want to make sure when we're doing a sound transmission calculation that we have enough rays to calculate transmission in the receiver room. You can see there's a job with, this is in the same room and the same room, and if we take this job that has a receiver in the office and a source outside in the hall, we can test with a calculation how the reflection density looks. This is a ray tracing. So the calculation takes maybe about half a minute. We go to the point response, and we can see under reflection density, yeah, it is really enough of rays to achieve a good reflection density. Perhaps then it would be interesting to calculate a grid response. So we can define a grid response in the room. Yeah, here is already one selected. This is the floor with the 1 meter between the receiver in the grid and a height above the floor of 1.5 meters. Looks like this. And perhaps we want to see the grid with a source in the hall to see how it will, how the sound pressure level will cover the whole hall, also inside the office, and make a calculation. While this is calculating, I can tell you that this example has also been used in an article that was made in 2008. You can find the article in PDF at the Odeon homepage. If you go to About, Publications, Papers in Proceeding, and then scroll down to 2008. Modeling airborne sound transmission between couple rooms from Bynam in Reykjavik. If you are interested in the background of how the transmission is calculated. Well, it looks like the grid response takes around 30 minutes on this computer. We can take a look at the point response already. This is a receiver in the same room, and we can see the sound pressure level is around 85 decibel, and compare it with the results when the receiver is inside the office. And there we have sound pressure levels down to 70 decibels. I think now the grid response should be calculated. And here we can see the sound pressure level when it's close to the source. It is up to 92 decibels at 1000 Hertz. And if we go into the office, it is about 50. Alright, well, I just finished the calculation. With the transmission indexes, you can also copy them in the opposite direction. So for example, if you want to have the transmission from this surface, you can go in here, press Control Copy, and then you can get it out as a value for the Excel sheet.